Hey everyone, Mr. Armitage here in part 3 of the Bubbafish activity. And so now we're finally getting to actually creating our confidence interval. But first we need to know about the standard error for our sample. And what the standard error is basically kind of like the standard deviation. It describes how all of our samples would be distributed if we did more than one, or if we got the same value again. And so the standard error of p hat is equal to the square root of p hat times q hat divided by n. So in our particular, or in my particular case, of course, your numbers will most likely be different. We can just substitute them in. So we have 0.22 times 0.78 divided by 50. Okay. And if I calculate that out, it's going to be the square root of 0.003432, which is approximately 0.0586. Okay, I'm going to go out to 4 decimal places, even though I don't really need to, but twice as many as our proportion, so works out. All right, so we have that there, and that's our standard error, and kind of the standard deviation of our sampling distribution. Now, what do we do with this? Okay, well, now we need to calculate our margin of error. Okay. So once again, this here was the standard error. Now we need our margin of error. And our margin of error is essentially, how sure do we want to be about our estimate of where the mean is, or the true population proportion. Sorry, not mean, proportion. Well, okay, according to the normal model, approximately 95% of values are in, plus or minus 2 standard deviations of the mean. Okay, so we're going to use that. Okay, our margin of error is our, how sure we want to be. So in this particular case, it would be 2 times our standard error. Now, strictly speaking, it's not always 2. It's actually something called, well, our critical z value, or z alpha over 2. Okay, so the 95% certainty that we want corresponds to a 5% uncertainty. So this z-score here, this z value that we could get by looking at our table, is the z value that corresponds to that particular amount of uncertainty. Okay. In our case, we're just going to say it's 2 because it's close enough right now. Okay. It's actually slightly less than 2, but we don't need to worry about that right now. So we'll have 2 times our standard error, which was 0.0586. Okay. Now, I just kept the original standard error in my calculator, so I'm going to multiply that by 2, and I'll still take it out to 4 decimal places. So that's 0.1172. Okay. So that is our margin of error. Now, this margin of error describes how certain we can be about what the true population proportion is. And so now, finally, we can make our confidence interval, okay, our 95% confidence interval for the population proportion. So a confidence interval for a proportion, it is going to be p hat, okay, plus n minus the margin of error. Okay. So you're going to end up with 2 numbers, an upper bound and a lower bound, right? An upper larger number and a smaller lower number. So let's get both of them. Okay. So in our case, or in my case, my proportion, my p hat was 0.22. And I'm going to add to that my margin of error. And I am also going to subtract my margin of error. So 0.22 minus 0.1172. And I'll go ahead and label these as upper and lower. Okay. So let's see here. Our upper value for our confidence interval will be 0.3372. And the lower number, or lower bound, for my confidence interval will be 0.1028. Okay. So these 2 numbers on their own are the confidence interval. Okay. So now we can say that we have about 95% confidence that the true population mean in this case is between 0.337 about and 0.103. So somewhere between 10% and 34% of the fish should have that third eye, just according to this sample here. Yours will be different, and we'll see how that looks.